We are on bell ringer number 10 today, so write down today's date, and you should have a worksheet, and you can put that down for your objective column. Next slide is your mind thinker. Can you read this? So pause and see if you can read this. I couldn't believe that I could actually understand what I was reading, blah, 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 blah. So it's either a yes or no answer there. Can you read it on your own, or did you need me to help you out there? How about this one? Pause. This one's a little trickier because you're really kind of taking words and splitting them up in different parts. So this is really what it means, or says, made with intensive studies, blah, 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 blah. So again, if you want to read that over and see how the words are separated, great. If not, no big deal. Write down yes or no if you could read those two things without me. Your element of the day, again, repeat after me, whisper or say in your head, francium. Can you find the symbol and the atomic number on the periodic table? Hopefully you did. Fr and 86, and again, write down your symbol and atomic number in those squishy boxes. Now, we're not going to go through this because I want to make sure I have enough time in this video to explain the worksheet because it's a little bit more detailed today, and that's what we're reviewing. We're reviewing the parts, how many electrons, protons, neutrons are on an atom of certain elements. So location, again, group 1, period 7. This element starts period 7. So group 1, 1 valence electron. The name of group 1 is the alkali metals. So it is a metal because it's to the left of that stair-step line. And it is a solid at room temperature. So again, pause the video, go to that element of the day, and make sure to write down a fact. So pause the video, put your bell ringer sheet away, get out your atom packet, turn to page 5-6. You should already have this worksheet titled Atomic Basics. If you don't, let a teacher know so you can get it. You should also have a calculator out. Again, if you don't have one, please raise your hand. A teacher will provide you with one. Okay? And again, for your worksheet here, you can use your cell phone, but on your quiz, which will be in a day or two, you will not be able to use your phone. You have to use a calculator. Okay, so first we're going to do some of the worksheet together. Then I'm going to have you do some on your own. Okay, so you should follow the instructions on this video. Again, you should be watching it, not skipping around. So let's review first. If we're looking at the parts of the atom, can you pause the video and again think about what I am pointing to, what the arrows are pointing to, and you can come up with the charge? Can you come up with the charge if appropriate? So I don't remember what order I have this in. You should have paused the video and kind of gave yourself a little review yourself, see if you can answer all these questions or label all the arrows. Did you get that this middle circle is the nucleus and it has a positive charge? So the P inside the nucleus are protons, which have a positive charge. The N stands for neutrons, which has no charge. The E's are for electrons, and they have negative charges. Now, today, you're actually going to understand how many electrons are in each of these rings, and those rings, again, are called energy levels. So the worksheet is going to help us understand how many electrons are on the first energy level, second energy level, third energy level. So we're really going to be taking into consideration where those core electrons are and how many of those valence electrons are. And of course, all of the energy levels together are called the electron cloud. So, again, in your notes, this information is there, but just as a reminder, the atomic number is going to give us those protons, which also equals electrons. The atomic mass is the entire number that's given to us on the periodic table, but that's not really helpful. So what do we have to do? We have to take that number and round it to a whole number. That gives us the protons plus neutrons. And I want to give this to you again. As a reminder, when we're rounding, the number after the decimal place, if that number is 4 or below, we're going to let the number go. We're going to keep it as is. But if that number, again, the number to the right of that decimal, the first number to the right of the decimal, if it's 5 and above, we're going to give it a shove. We're going to move it to the next number. And of course, to find the number of neutrons, we're going to take that mass number that we rounded to a whole number minus the atomic number. Why are we doing that? Because you can't have a decimal place for the number of neutrons. They all have to be whole numbers. Okay, so now let's look at this worksheet. So, part A. First, you have this atomic structure over here, and it says we're going to draw 5 protons in the nucleus. So this gray area, we have to put in 5 protons. And you're going to also label them with their charge. So this is what I did. Put your name first. Obviously, put your name on the paper. We are going to collect it for points. So I just put 1, 2, 3, 4, 5 positives in the nucleus. That to me shows me that you understand there are 5 positive protons inside the nucleus. So pause the video and make sure you do that. Number 2 says draw 6 neutrons. Again, neutrons are really no charge, so I'm just going to make some circles. So 1, 2, 3, 4, 5, 6. So I put 6 neutrons in the nucleus. Now it says draw 2 electrons in the first energy level. So now remember, these are energy levels. So we only need 2 in the first energy level. So I'm just going to put them E with a dash. E with a dash. That negative, that shows me that E has a negative charge. Now it says draw 3 electrons in the second energy level. So 1, 2, 3. And again, it doesn't matter where the placements are, as long as I can see that you have 2 on the first energy level and 3 on the second. That's going to be really, really important for later on when we're checking your work, okay? So if you haven't done so far, pause and make sure you have all of that on your paper. So it asks, what element does this represent? Well, there's 2 ways to figure that out. You can either count up the protons, because that equals the atomic number, or you can count up the electrons, because that also equals the protons, which also equals the atomic number. Then when you find the atomic number, you can look on your periodic table. They're all in order, right? The atomic number goes straight in order, so that's easy to find. So, hopefully, that's kind of what I said, right? Count either the protons or electrons equals the atomic number. I have 5 protons or 5 electrons. The atomic number is 5. So if you haven't found it yet, again, pause, look at your periodic table, and you should have boron. So make sure to write that in. And I have this over here as well, because again, it doesn't matter how you're writing or drawing, as long as again you're showing those positive protons, and I just always like to write electrons with a negative. So, part B, label the following. Again, pause. See if you can figure this out, at least in your head first, and then we're going to go through it. So what does that 8 represent for this box of this element? The atomic number. Again, up to you if you want to pause each time and write it, or let me finish the slide and then pause and write in your thoughts. What does that O represent? That O represents the symbol. What does oxygen represent for that element? Its name. And what does this 15.999 represent? Again, the atomic mass. So it's up to you again. You want to pause and write this information or continue on. Number 7, we're looking over here now. What does that atomic number represent? Remember, it's going to equal 2 things. We should remember that it equals the protons or it equals the electrons, right? So if I have the atomic number of 8, that means I have 8 electrons, which means I have 8 protons. So what does the atomic mass represent? Again, now this is a plus sign, like a sum. Well, what does that sum give us? The protons plus the neutrons. So number 9, how would you figure the number of protons or electrons in the atom? I kind of explained that to you already, right? That atomic number is going to give us the number of protons, which also equals the number of electrons. And number 10, how would you figure the number of neutrons? Okay, so now that we have these 2 numbers, the atomic mass, which is rounding the atomic mass to a whole number, right? It should really say mass number there, because we have to round that, and then we're going to do some subtraction. So first round the atomic mass to a whole number, and then subtract mass minus atomic number. Okay? So again, at this point, make sure you have all of this information written down. So number 11, very similar, not exactly the same, but very similar to your notes packet. So the first thing I want you to do is write down where we're going to find this information. So the atomic number comes from the periodic table. The atomic mass, again, I don't like that. I'm just going to put mass number there, and that's going to be that periodic table rounded atomic mass to a whole number. The protons is going to equal that atomic number. Neutrons is going to mass minus atomic number, and electrons is atomic number. So again, make sure that you have that information down. Now, again, this is a little trickier because the order of the columns is different than what you're used to, but it's the same information, and this is why we do this first. Okay, so now let's do the first 3 rows together. Okay, so lithium, they give us the atomic number and the mass. So what are our protons? Easy. Neutrons, we're doing our subtraction. Again, use your calculator. 4, and electrons, 3. How about for P, phosphorus? Again, they give us the atomic number and mass number, so the protons should be easy. Get out your calculator. 31 minus 15 gives you that 16. And again, electrons is 15. So in this case, the atomic number, the number of protons, and the number of electrons. Remember, those 3 columns will always have the same number. So chlorine, even without the calculator, you can figure out the atomic number. You don't even have to look at the periodic table because it gives you the number of protons. So since the number of protons is 17, so is that atomic number. So the neutrons you're subtracting, and the electrons is 17. So now you're going to finish the rest, and yes, we will be checking this for correctness. So pause the video, finish the chart, and then continue playing the video. So you may read that. Now let's move on to part C. Number 12, you might not know this, but we did talk about at least the first energy level always has 2 electrons. Second energy level has 8, and the third one is going to have 18. So when we have a lot of electrons, those electrons, their specific electrons, go on very specific energy levels. Okay, and number 13, I just answered this. I think that's why I said the word valence, right? We talked about how those last or outermost energy levels, those outermost electrons are called valence electrons. So number 14 is going to help us out here. They're giving us the atomic number and the mass number. So the number of protons is, neutrons is, and electrons is. Now they want us to figure out these electrons and where do they go on this atomic structure. So remember, 2 are going to go on the first energy level, and that's what it says here. We're going to always refer back to this number 12. 8, and it doesn't really matter the order, 8 is going to go on the second. So 2 and 8 is 10, and we still have 6 more to go. So we can fill it up to 18, so we're going to just put all 6 on there. Now this Lewis structure is really just showing us the valence electrons. Well, how many electrons are on the outermost energy level? Here is 6. So now we're going to put 6 dots around this sulfur. 1, 2, 3, 4, 5, 6. And what I like to do is I like to think of this sulfur in a box, and I put 1 at each side of the box, and then I start pairing up. So technically sulfur has 2 pairs of electrons and 2 single electrons. So it should make sense because in group 16 has 6 valence electrons. That's another way to look at it. So again, we'll do the first 2 together, okay, and then you can pause and do the rest. So for lithium, again, it gives us your mass and atomic number, so protons, neutrons, electrons. Now let's focus on these electrons. There's 3. So 2 go in the first. Again, refer back to number 12 if you need to. And so 3 minus 2 gives us 1 left over for the outside. So now for our Lewis dot structure, we're going to put 1 electron on lithium. Again, it really doesn't matter where. Now, can you pause, do neon, see if you can do it and check your work to make sure you're doing it correctly. So, protons, neutrons, electrons. We got 10. 2 on the first, 1, 2, 3, 4, 5, 6, 7, 8 on the second. That makes 10 electrons total. So, neon has 8 valence electrons, so we need 8 dots around neon. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and again, it really doesn't matter the order, but I like to do 1 on each side before I pair up. Now, the rest of the time is yours to do magnesium, chlorine, helium, and silicon. Again, if you have questions, please call over a teacher. I didn't mean to do this again. Sorry, I must have doubled it. I don't know why. Sorry. Here we go. Okay, so now you should have paused the video. You should have completed number 15. Again, we're going to check this for correctness, so make sure you're doing it right. And these guys, we've talked about it a little bit, so I'm going to quickly go through these answers. Number 1, filled outermost electron shell. Again, referring back to 12 would be neon and helium. The element that loses is going to be lithium. It's easy to lose that 1 valence electron. Chlorine for number 3. And 4 is going to be, again, neon and helium because they have that filled shell. Okay, raise your hand and hand it in.